In this video, I want to start chapter 4. Chapter 4 is going to be all about vectors and the different things that we mean when we talk about vectors. There's going to be a few different perspectives that will be very useful for us when we talk about vectors. The first, when we say a vector, is what we mean by a vector in Calc 3. So section 4.1 is about vectors in R2, or more generally Rn. Okay. R2 is just how we write the Euclidean plane. So this is the set of all points x, y. So there's a few different ways that I want to think about this, but R2 we can think of as the set of points x, y, where x and y are real numbers. They're in the set of real numbers. I might as well write this the real way. So x and y are elements of the real numbers. Okay, so this funny symbol here means is an element of. And R stands for the real numbers. Okay, by the real numbers, what I mean is the set of numbers that includes things like square root of 2, e, pi, 7, negative 31, and so on. Right, so these are, I think of real numbers, kind of a nice short definition is real numbers are the numbers that you can write out with a decimal expansion. So again, things like pi, e, square root of 2, but also 7.1, negative 3, and so on. So R2 is the set of ordered pairs, and we can think of this as the Cartesian plane. Okay, so this is the set of points. This is the usual plane that you work with in grade school, high school, whatever. And so this is R2. Rn, more generally, you can think of as the set of n tuples. So R3, for example, is the set of triples. R4 is the set of quadruples. Rn, in general, is a set of n tuples, where each of the coordinates is an element of the real numbers. And even if you can't geometrically make sense of that object, it makes perfect sense to talk about it mathematically. Right? R4 we could just talk about as the set of quadruples, right? X, Y, Z, and W typically, where each of those elements is a real number. Even if it doesn't geometrically make sense, we can still talk about things like adding vectors and so on. So that's what we want to get into, is talking about vectors in R2, what it means to add, and so on. Now, one other thing I want to point out, and there's a slight possibility for confusion here. If I have a vector, say 1, 2, okay, this is different than to talk about the point 1, 2. So the vector specifically is an object that has a magnitude and a direction. In our case, what it's going to do is it's going to take the origin and map it to the point 1, 2. And so when I think of the vector 1, 2, and sometimes I'll write an arrow over top just to remember that this is a vector versus a point. When I think about a vector, I think of it as a set of instructions. And what it does is it says wherever you start with, move to the right 1 unit, move 1 unit in the positive x direction, and 2 units in the positive y direction. Now, this same vector I could take, and we could move it all over the plane, as long as it points in the same direction, and as long as it has the same length. So everything that I'm doing here about moving this vector all over the place, it's the same vector. It doesn't really matter where we start it. Traditionally, we start the vector at the origin. And so I just want to kind of compare what this means. We're comparing this vector 1, 2, which is a set of instructions that you give to a set of points. And what the instructions say, again, is to move 1 unit to the right and 2 units up. That set of instructions is different than the point 1, 2. The point 1, 2 is not a set of instructions. It's just this red point here. It's just a point. It's just sitting there. It's not doing anything. It can't do anything. It's just a point. So I just want to contrast the difference there. Now, there's an obvious correspondence between the vector 1, 2 and the point 1, 2. And the correspondence is that if you start the vector at the origin, what the vector is doing is it's taking the origin and moving it to this point. Okay, so there's these objects are related, but they are distinctly different in what they are. And I want to get to studying this set of vectors. Okay, so again, a vector is a quantity with a magnitude and a direction. And I think of it as a set of instructions. It just says, wherever you start with, move however many units in the x direction and however many units in the y direction, and that's where you're going to end up. Okay, so that's a vector. Also, the reason why we're talking about vectors here, there's a multitude of reasons, but one is that you can think of a vector as a 1 by 2 matrix. So a vector in R2 you can think of as a 1 by 2 matrix. You can think of this as, so you can think of this vector V as a 1 by 2 matrix. So you would have 1, 2. Okay, and so when you think of it in that sense, all the next things that I'm going to say are going to make total sense. They're going to seem kind of silly, possibly even boring, but I want to just go over all of the details and all the things that we can do with vectors. So the first thing that we can do with vectors is we can add them. Okay, so we can add two vectors. If I have two vectors, let's say v1, which is 2, 5, and v2, which is -3, 1, then we can add these two vectors. This is going to give us a new vector, and the sum of the coordinates is going to be our new vector. So we end up with -1, 6. And this makes total sense if we think about our vectors geometrically. Okay, so this first vector says start at the origin and then move up 5 units. Move right 2 units and up 5 units. So that's the first thing. The second vector says, move to the left, move 3 units in the negative x direction, and then up 1 unit. Okay, so if we were to take 1, 2, 3, and then what we're going to do is when we add these two vectors, it's kind of like we're doing one operation right after the other. So imagine that you're putting this tip to tail, as they say, and so that's going to create a new vector, which is going to be -1, 6. So that's like moving 1 in the negative x direction and 6 in the positive y direction. Okay, so that's what vector addition means. That's kind of the geometric interpretation. Okay, that picture I know is not the best, but hopefully it gets across the idea here. So that's vector addition. Likewise, we can talk about vector scaling. So if I were to have a vector, say 1, 2, then 3 times that vector would be 3, 6. Again, not terribly exciting, but I think it's worth just pointing out what this means geometrically. Okay, so the vector v says we're going to go so v itself, let's make v red, just to help us distinguish here with the colors. So the vector v says we're going to go 1 in the positive y and the positive x direction and 2 in the y direction. So that's there. So 0.1, 2. And if we were to scale that, if we were to do that 3 times, in other words, what you would end up with is the vector v, which is going to point in the same direction. It's just be 3 times as long. Okay, so that's the vector v versus 3v. And then once you have these, so once you can talk about scalar multiplication, then you can also talk about subtracting vectors. So if we were to have v1 minus v2, you can think of that as adding the negative. And by the way, I should point out that when we talk about, this is also something we're talking about here, and we can just squeeze it in here. When we're talking about negatives, if I were to do negative v, this would be -1, -2. And what that's going to do is that's going to tell us keep the same angle that the vector makes, but we're going to go in the opposite direction. So it's going to be the vector that's completely antipodal to the original vector. Okay, so it's going to go antipodal, by the way. So it's going to go in the opposite direction as the original vector. Okay, so if we were to think of v1 minus v2, we can think of it like this. So v1 plus minus 1 v2. Okay, so again, this is just taking our previous operations that we talked about of vector addition and vector scaling and putting those together. So that's vector differences.